In this video, we're going to talk about how to solve problems involving direct and inverse variation. So direct variation occurs when you have two variables x and y that are related by the equation y equals kx. K is a constant that's known as the constant of proportionality. A direct variation equation will be a linear function. In word problems, you'll see that it says y is directly proportional to x, or it'll say y varies directly as x. So you can see in the examples y equals 1/2 x and y equals negative 4x that we have direct variation. In this first equation, the value of k is 1/2, and in the second equation, the value of k is negative 4. So inverse variation happens when two variables x and y are related by y equals k over x, which can be rewritten as xy equals k. An inverse variation will be a rational function, and the problems will say that y is inversely proportional to x, or y varies inversely as x. So you can see that the equations xy equals 24 or y equals 3 over x are examples of inverse variation. In the first equation, the value of k is 24. In the second equation, the value of k is 3. So let's look at some examples. So it says that the cost of shipping a package C varies directly with its weight in pounds W. A package weighing 7 pounds ships for $19.25. Find and graph the relationship between the weight of a package and its shipping cost. How much will it cost to ship a 14-pound package? So it says that the cost varies directly with its weight in pounds W. So this varies directly. It's our very important phrase that we need. That tells us that we have direct variation. So our variables are going to be related by y equals kx. So it says a package weighing 7 pounds ships for $19.25, and then we want to find how much will it cost to ship a 14-pound package. So let's start off by identifying our variables. We have C, which is the cost of shipping, and we have W, which is the weight in pounds. So we know that we have direct variation, so we know that y equals kx. Well, in this case, it tells us that C varies directly with W. Okay, so we can write that as C equals k times W, just so it's adjusted for the context of this problem. So we have two values that we can use, and so let's substitute in those given values. So it says weighing 7 pounds, so we know that W is 7, and we know that the cost is $19.25. So we can say $19.25 equals k times 7. So you see, now I have an equation that I can use to solve for the value of k, which is the constant of variation. If I divide both sides by 7, that will give me 19.25 divided by 7, which is $2.75, and that is the value of k. So I can rewrite this equation as C equals 2.75 W. That is the direct variation equation that I have for this problem. Well, notice that it says to find and graph the relationship. So I'm going to graph this in Desmos. So when I'm graphing in Desmos, I'm going to just, instead of calling this C and W, I'm going to call this Y and X. So I'm going to say Y equals 2.75X. So when I do that, I can graph it. You can see here, this is the graph of the function. Notice that it is linear because direct variation will be a linear relationship. Okay, so that's something to notice that when you create the graph of this function. So now there's one more part to this problem. It wants us to figure out how much it'll cost to ship a 14-pound package. So to figure that out, so I have 14 pounds, and I have this equation that I just wrote, C equals 2.75 W. So I can just substitute 14 in for W, which is the weight. So I have C equals 2.75 times 14. And when I solve that, I have 2.75 times 14, which gives me 38.5. So that means it will cost $38.50 to ship a 14-pound package. So in this problem, it says that the time y that it takes for a group of students to paint a large classroom is inversely proportional to the number of students helping x. If 4 students can paint the classroom in 9 hours, how many students would need to help in order to finish the job in 3 hours? Make a graph comparing the number of students to the time needed to paint the classroom. So let's look at our important information. So we have time is y, and it says that it's inversely proportional. Okay, so there's our very important phrase. So we know that our variables are going to have the relationship x, y equals k, where k is some kind of constant. And we have the number of students helping, which is x. So it tells us that 4 students can paint in 9 hours. And then we want to know how many students would need to help to finish the job in 3 hours. We need to make a graph. So let's go ahead and get started. So we have y, which is the time, and we have x, which is the number of students. Okay, so let's define our variables. So it tells us that we have inversely proportional relationship, right? So it says y is inversely proportional to x. So we know that we have this relationship x, y equals k. So now let's substitute in the given values. We have 4 students can paint the classroom in 9 hours. So we're going to substitute 4 for the number of students and then 9 for the number of hours. So we have 4 times 9 equals k, which tells us that 36 equals k. So that means that my direct proportion relationship is going to be xy equals 36. So I've figured out this equation now. So what I can do now is I can graph this. It wants us to find the graph. If we have xy equals 36, I can write this in terms of y equals. I can divide both sides by x. And I can also write this as y equals 36 over x. Okay, so these two are the same equation. So I graph this as y equals 36 over x. And you can see that this is the shape of the graph. Okay, so when we have inverse variation, we have a rational function. So that's why the graph looks curved like this. Inverse variation is a rational function. So let's go back to our problem. So now it wants us to find how many students would need to help to complete the job in 3 hours. Okay, so let's use that equation. We have xy equals 36, and it tells us that y equals 3 hours. So we need to find the value of x. So we have x times 3 equals 36. If we divide both sides by 3, we get x equals 12. So we would need 12 students to finish the job in 3 hours. So in this problem, it says that several co-workers carpool to work each day. The $12 daily cost of buying gas is split evenly among the people who carpool that day. Is this an example of direct variation or inverse variation? So let's see the important information we have. We have several co-workers, and there's a $12 daily cost, and it's split evenly among the people, and we need to figure out direct variation or inverse. Okay, so let's start off by identifying our variables. So we could say that the number of coworkers let's call that x, and then we say how much it cost each person, right? So cost per person would be y. So if we were going to write an equation to figure this out, okay, so we would say like each person is going to pay y. There's a $12 daily cost, but then it's going to be divided among all those people. So we could write this equation as y equals 12 divided by x, right? So if we write the equation like this, notice based on the format of this equation that it is going to be inverse variation. Okay, so this is going to be an inverse variation relationship, and the way you figure that out is by writing an equation that relates the two variables in the problem. So now you can go ahead and pause the video and try this example on your own. So in this problem, it says that Jessica wants to know the total cost y of buying X identical notebooks at the school store. Each notebook costs the same amount. Determine what type of variation this is. If it costs $10 to buy 8 notebooks, how much would it cost to buy 13 notebooks? So what we did is we defined two variables, y for the cost and then x for the number of notebooks. So we talk about the total cost, we know that it's going to be the price times the number of notebooks that she buys. So in other words, that's basically y equals k times x, where k stands for the price. So we would say this is an example of direct variation. So we can write this equation, y equals kx, and then substitute in 10 and 8. So we substitute 10 and 8, and then we solve for the value of k, which gives us 1.25. So we now have the equation y equals 1.25x. So now we can just substitute in the situation that gives us the 13 notebooks, and so that gives you y equals 1.25 times 13, which tells us that y equals 16.25. So it'll cost $16.25 to buy 13 notebooks. So in summary, given a situation, you can determine whether it represents direct or inverse variation by setting up an equation to represent the problem situation. Direct variation occurs when the two variables are related by y equals kx. Inverse variation occurs when the two variables are related by xy equals k, which remember that can be rewritten as y equals k over x. In both equations, the value of k will be a constant.